Okay, today I want to show really quick. I had somebody ask me a question, and I've actually received this question a few times, so it's time to do a video on it, so I can stop getting the question. People just getting into working on radios, and they're trying to do an alignment on a radio. It can be a CB radio, an amateur radio, doesn't matter. It's a transmitter. And what they're trying to do is connect their signal generator to the microphone jack. And most of the time, that works fine. You just take a BNC cable off of your signal generator, hook it up. Now, I've got little homemade adapters for all different kinds of connectors and whatnot, but I just have a bunch of these I've made up over the years. It's just a BNC jack, mic jack, plug pulled out of the body, stuck on some perf board with a little toggle switch so I can switch between, receive and transmit. But that allows me then to switch into transmit or receive, and the BNC jack allows me to connect this to the signal generator. So I can inject, let's say, if I'm doing an AM modulation adjustment, I can feed 1,000 hertz audio tone into the radio, or if I'm doing a double tone test on sideband, I can feed that double tone into the audio jack. A problem you'll occasionally run into is you'll hook up your BNC cable here, and your audio just looks horrible on the oscilloscope. It's basically, if you've ever experienced feedback squeal with a microphone from RF energy leaching back into it, it's kind of the same thing. And basically what has happened is, and I run into it here too. That's why I'm actually going to make another one, because I figured, well, I could actually use another one of these. I've made up several of them over the years. They all look different because I just happen to use whatever little box I happen to have lying around. But the problem you're having is you have a ground loop. The problem is your signal generator, be it a new, digital style like that or an old antique. It can be an old vacuum tube operated one. Might not even have any tubes. Might just be a Colpitts oscillator style with just some passive components. But the big problem you have there is the ground on that BNC connector right there, the outer shield, is attached to ground. So you plug in, where you're plugging into the wall. And you can end up with a ground loop. That's usually what happens. Either because then with a transmitter, you've got your antenna connected to a dummy load or something, or if it's connected to a piece of test equipment, because if you're doing modulation adjustments, well, you've got a sample going to your oscilloscope, you can get weird ground loop problems. So what you need to do is isolate the audio so it has absolutely no ground reference. And we can do that very simply with a little tiny isolation transformer. We don't need a big, huge isolation transformer, because honestly, we're only feeding usually a few millivolts into a microphone jack. 5, 10, 20, 30, maybe at a maximum, some radios may tell you 100 millivolts, when you're adjusting clipping or something like that. But it's a very low signal, so even 100 millivolts peak to peak, that's not diddly squat. So we don't need big isolation transformers. All we need is something like this, these little tiny guys here. So you can pick these up pretty much anywhere. Most electronic suppliers are going to have them. You can get these probably on Amazon. I think I don't remember which one, but one of these, I think I've got bags full of these things. I think one of these I might have actually gotten on eBay at one time, but that's all you need. Now, I have two of them here because I work on lots of different types of stuff. One is a 600 ohm and one is a 10,000 ohm. So the reason I'm using two of them is because I work on old vintage equipment as well. Most old vintage equipment had what was known as a low Z, or Z for impedance, so it was a low impedance. Modern radios are high impedance. So yeah, 600 and 10,000 ohms is pretty good, and those are common isolation transformers, and they're cheap. They don't cost much. Trust me, the little box, if you buy a box and some BNC jacks, it's going to cost you probably a lot more than the transformers themselves. Now, if you only work on solid-state radios, you could probably get away with a 10,000 ohm impedance matching or not impedance matching, but an isolation transformer. And that's the key here. These are not I guess you could say they're not actually transformers in the sense that it's not transforming anything. It's not, one impedance on the input and a different impedance on the output. The impedance on both sets of these terminals, so there's two terminals on each side, it's exactly the same. It's 10,000 ohm impedance here and 10,000 ohm impedance on the other side. Same thing goes for the 600 ohm. One side 600, the other side is 600. All it's doing though is it's isolating it. These wires have absolutely no electrical connection to these two wires here. Same thing with this. These two terminals have absolutely no electrical connection to these two wires here. It's a transformer, so it's enamel-coated wire, and then sometimes they even have plastic wraps in there. But the wires are not actually touching each other. So that allows you to hook up your signal generator basically to the input, in either side. It doesn't matter. There is no input and output on these because both sides are exactly the same. So you basically just hook up your signal generator on one side, the other side would then go to the radio. Now, you want to try and keep stuff shielded, so I always put them in little metal boxes. I happen to have a bunch of these laying around. I need to strip off the writing on this so I can relabel it. But this actually started out life as one of these. I think I got like 5 or 6 of these things. It's an impedance adapter, but this is a 1000 ohm. Use this when you're working on stereo equipment. But like I said, I've got a bunch of them. I only need one of them, so I'll scavenge the other ones to use for little project boxes. And this one, it's going to be a tight squeeze, but I can get this transformer down in there, push it up to where the plastic's touching that, but I can get the pins to that, run some little small wires from those pins over to that jack, and then I can get this little transformer dropped down in there. Actually, I'll install this one first up under there, and that's all you need. So this will do 2 different impedances. I'll have one of them, one set of BNC jacks will be 600 ohms in, 600 ohms out. The other one will be 10,000 ohms in, 10,000 ohms out. And like I say, it doesn't matter which you use as the input and the output, because the transformer is exactly the same on both sides. It's not stepping up or stepping down like usually you would use a transformer for. Like I say, if you're only doing 10,000 ohms, you don't need 4 jacks. And there is not going to be any connection between both sides. So this is basically 2 completely separate little isolation circuits. They're just going to be in one box because I'm only ever going to be using one of them at any given time anyhow. So let me get this little thing wired up and I'll show you what it looks like when it's done. Now, as far as boxes go, this is a key thing you need to remember. I'm using a metal box for shielding. The big kicker here is make sure when you use BNC jacks, ideally you should be using isolated BNC jacks. The reason I say that is if you use a normal, you see how this is plastic on the back side. It's white, and you can see how it's white right here. Now that black stuff is actually, because this little box, the holes that were in this are actually a little bit too big for the BNC jack. So when you stick it in there, it wobbled in the hole. Now, I have stockpiles of anything made by man that's old, so I have a stockpile, of course, of little extruded fiber washers from way back in the day, but they're step washers. You can see it has a little step on it. They fit perfect into the holes that were in this box on the outside diameter of that step, and then the inside diameter is exactly the right size for a BNC jack. That's the only reason there is. It's just basically to take up the slop in the holes. But I'm specifically using isolated BNC jacks. So the metal shield on this BNC jack has absolutely no connection to that nut. So if you were to stick a normal BNC jack into a metal box, when you tighten the nut up, that BNC jack, the shield on the BNC is going to be touching the outside of the box. Now if that box should then, now granted, you have an isolation transformer in here. They're isolated, but both of those BNC jacks, if they're both touching the metal box, well, you've effectively attached one side of the transformer then to the other side of the transformer. Now, you could get away with one isolated and one solid metal. I would suggest going with all isolated. You want absolutely no connection whatsoever from your connections to the outside world, other than the radio to one side isolated to the other side, which goes to your radio's microphone jack. So you can get I think these are Amphenol, I believe. Yes, I had to look on the box there to find it. I don't know if it shows up in the camera, but it's actually printed right there. It says Amphenol. And these are model number, what are these, RFX, I think. Yeah, that's all it says on there. They're RFX. I can't remember right off the top of my head what the actual number is on it, but you can look them up. Just, if you search any electronic supplier, just isolated or insulated, either way, it's the same thing, isolated, insulated. But that's what you want for BNC jacks. Like I say, that way there's no connect, because that's your problem. You're having connections between the ground on an input, or from the signal generator to your whatever test fixture, or however you're attaching to your radio, and you don't want that ground attached. You want it completely isolated to prevent ground loops. So this is the easiest and probably cheapest way to do it. Like I say, you don't need a little box like this. Now, as far as boxes go, Pomona makes boxes. They're usually not going to have 4 jacks in it, but you can buy, Pomona makes little project boxes, kind of like this, and it already has pre-installed BNC jacks in either end. Be careful though, those are not isolated. So that's the big kicker. Whenever you're doing this, make sure you have isolated jacks. There's no connection between that and the box body itself. You could use anything. I mean, shoot, you could buy little project boxes. Like I say, I'm only using metal just for extra precaution. I want to make sure I have really good shielding, because I can tend to work on very high power, especially if I'm working on amateur radios. You can get 100, 200 watt transceiver. You might get a little bit of RF feedback into your audio circuit, so I'm trying to eliminate that. If you're only working on CB radios, honestly, probably a plastic box would be fine. So you can get little small plastic boxes for just a couple bucks. The advantage is if you use a plastic enclosure, you don't have to worry about isolated or insulated BNC jacks then. The box is insulated. Just be aware though, you can get some RF feedback, but if you're only operating, CB radio stock wattage, 4 to 12 watts, I seriously doubt, unless you've got the antenna standing up on the bench right beside the little box, I seriously doubt you're going to have feedback problems. But like I say, if you use a plastic box, that eliminates that problem of the BNC body grounding through the actual box itself. So let me get this little thing assembled, show you what it looks like, and then I can probably even grab a radio, toss a radio here on the bench and show you. Like I said, it's basically just an inline isolation. That's all you're doing. Signal generator in, out to your radio is all it is. So let me get this little critter assembled. Okay, so I got her all assembled now. So we got the little transformers in there. Like I say, these two will be one transformer, these two will be another. So it's a dual use box. Can be used with high or low Z or low high impedance. I did take a little bit of just a Corona dope kind of dribbled down in there so the transformers can't move around. Not that there's going to be enough energy going through this thing for the coils to vibrate, but just so nothing can ever possibly move and short out. So dribbled a bunch of Corona dope in around both the transformers and the connections, and then stuck this in my little curing oven it's actually still rather warm, still probably about 140, 150 degrees Fahrenheit. It's cooling down though. So let me get the cover on this. What I think I'm going to try to do is I'm going to try to find a radio that demonstrates the ground loop problem when it's connected directly to a signal generator, and then how that problem will magically disappear when we install our little isolation transformer in series with it. So let me get this put together and try to dig out a culprit of a radio. Oh my God. It took twice as long to find a blasted radio that I could demonstrate this problem on than it did to assemble this blasted thing. It never fails. And I can guarantee you probably the next radio that I work on, it'll demonstrate this problem. But in any case, so I've got one of my radios here. I've never done anything to this. I bought it, or it had not even opened up yet to inspect yet, so I haven't done anything to it. I know it, I wrote on the note it's got, I guess, extra channels. I've discovered on some of the buttons. But yeah, this is a President Grant. Something one of these decades I need to restore, remove the extra channels, and basically just put back to stock. I'm going to assume that the modulation limiter has been snipped out of this thing, because yeah, you can get horrible distortion. But it demonstrates the problem of ground loops when you're trying to feed audio into your radio. So I have my little test board here. Okay, I've got an adapter because this is a 5-pin mic radio. Actually, here's the factory microphone, so 5-pin. So I have a 5-pin to 4-pin adapter, but I'm just using my little made-up little adapter board here that I can switch into transmit, and then I can feed my audio into. So we'll stick that in there. I have the, actually just out of view, I have that signal generator set currently to output 1 kilohertz audio tone. And it's currently the output is turned on, little green lights on right there. So if I can get this all in view, get the camera back too far, it's right in my face. Okay, so you can see the board. So if we flip the radio into transmit, you can see for starters we have way too much carrier. This thing's putting out like 5 3/4 watts, so yeah, the carrier's way too high. But we're going to take our audio now and hook it up to the board. And that does not look good. Neither does that down on the spectrum analyzer. Yeah, it's just, there's something seriously wrong. And you could very easily hook up something like this, see this, and think there's a problem with the radio. No, actually there's nothing wrong with the radio. All we're going to do now is, we're going to leave it keyed. We've unhooked the cable. I'm going to plug the cable into the 10K transformer, because remember there's 2 of them in here. I've got 600 ohms on this side and a 10K on this side. Now I've put a BNC adapter here because so I can actually attach it down there, and we'll hook this up, and you can see looks perfectly fine. Look down at the spectrum analyzer. Yeah, it's the all the spurs out there should be down a little bit. Like I say, I think the limiter is clipped in this, but you can see our huge distortion. Yeah, it just looked horrible. And if you were to listen to that on a receiving radio, it would sound probably like a feedback squeal, and that's what's causing it, is that ground loop. So you've got the, it could be either coming from your DC power source, it could be coming from your antenna connector, because remember, the shield on the antenna connector is attached to this chassis. That goes up, in my case, goes up to a bird directional coupler, then to a mini circuits splitter combiner to split it so it can go out to multiple instruments. But the thing is, that shield continues, that's the ground, it just continues through all of those adapters, and then comes down and feeds into the oscilloscope, and that also attaches the ground down here. So that's attaching earth ground, which is what the jacks on those are attached to at their power. Let me unkey this thing before I blow it up. But the BNC jacks on both of those instruments are attached to basically the ground pin on the power cord that's plugged into those. So yeah, you can just end up with weird ground loops, and like I say, it's usually, I see it all the time, but yeah, of course when I want one I can't find one. But yeah, so luckily we did find one here, so we'll do it again. I'll switch it into transmit. You can see, nice stable waveform. Doesn't look fantastic on a spectrum analyzer, but like I say, it's a butchered radio apparently. We'll just disconnect, take our transformer out of line, hook the BNC cable back up, and you can see, yeah, it's not looking good. So that's what the isolation transformer will do for you. So unkey that and turn this critter off. So that's all you need to do. Pick your, like I say, you can get them on, most electronics suppliers have them. Amazon, I know you can find them on eBay. For some reason, usually the 10Ks cost more than the 600 ohm ones, probably because they're usually bigger. Actually, you can just see the blue one here is a 10K, the little red ones here, these are 600 ohms, and you can see, yeah, it's like 2 times the size or bigger or more in size. So yeah, that's why these probably cost more. But even then, they're still relatively cheap. They don't cost that much. Like I say, get yourself a little project box. If you're not too concerned about RF feedback, if you have, I mean, honestly, I could probably get away without the metal box because I'm using good quality cables and everything here, so I don't really have a lot of RF emissions problems here at the bench. But just to be safe, because I can deal with high wattage occasionally, I like to use metal enclosures for shielding. But the big thing there is, if you're using a metal enclosure, make sure that you use insulated or isolated BNC jacks so you're not just recreating that ground loop path, because that's the whole purpose of this. That transformer completely isolates this jack from this jack, or completely isolates this jack from this jack. There's absolutely no electrical connection between the center pin or the outer jack, between those two or those two. If you inadvertently connect them, you might as well take the transformer out of it and just throw it away, because you've effectively removed the isolation. So there you go. I hope that helps. Like I say, get out there, pick yourself up some little either 10,000 or 600 ohms. If you work on mainly just solid state radios, really all you need is a 10,000 ohm one, so basically a high impedance. If you work on older equipment, tube type, whatnot, you're probably it wouldn't hurt to get 600 ohm transformers as well, or at least one. It's not like you need a bag full of them, but pick yourself up a 600 ohm as well. You might find that handy for working on older equipment. And then you can also get transformers, depending on what you're using for a signal generator. A lot of the older audio signal generators were 600 ohm output impedance. Well, what if you need to take that 600 ohm output impedance and you want to attach that to something like this radio? Well, this radio, it'll usually work fine, but ideally you should be matching your impedance. So you can get transformers that are actually transforming. Like I say, these are one-to-one. They're really not transforming anything. They're just allowing the AC to go through with no level change. It's not a step down or a step up transformer. It's a one-to-one ratio. But you can get transformers. So if you wanted to outmatch, let's say, an old school signal generator that had a 600 ohm output, and you want to be feeding it, and you want to try to keep the impedance match correct for the radio, you could get like a 600 to a 10,000 ohm matching transformer. It's still going to isolate, so it will eliminate the problem I just showed here, but then on top of that, you'll also be able to correctly match the impedance of your test equipment, your audio signal generator, with the actual radio you're attaching it to. Now, if you're attaching that 600 ohm output impedance signal generator to an old tube radio, you don't have to worry about it, because old tube radios, the majority of them are going to require a low impedance to start with, so it's already an even match. But when you're working on newer stuff with old equipment, then it doesn't hurt to get stuff like that. But like I say, just for isolation, pick up one of these little guys. It'll work wonders for you. It'll make these things that may appear to be a problem with the radio, when actually it's pretty much a problem with your equipment. And it's not that there's anything wrong with your equipment. It's just there are so many things. You can get so many pieces of equipment attached to a radio at the same time, and you just end up with a ground loop. And trust me, you can pull your hair out trying to figure out what it is that's causing the ground loop. You don't have to worry about it. Isolation at the audio input, no more loop, because there is no more ground. Okay, after I got done, cleaned the bench off, I got to thinking, for some people, I tend to build my stuff indestructible because I'm using it 7 days a week. Pretty much almost 365 days a year. And I want it to last a lifetime. But if you're doing this as a hobby, well, maybe you don't want to even put it in a box. You just need something quick that you can slap together. Again, going to need the isolation transformer, whatever impedance, ideally get the impedance that you need, like a 10K. Probably. Now you could just throw that little transformer on a piece of perf board, a piece of circuit board, perforated circuit board, and then just use a pair of BNC jacks like this that are circuit board mounted. Just stick them on there, transformer in between. Again, just make sure you don't connect the shields or the outside bodies to the same ground plane. Make sure they stay isolated. You could also very well just have a piece of take a BNC cable, cut the cable in half. If you get a BNC cable, let's say, whatever length you want that would get from your signal generator down to your little test fixture, cut that cable in half and just install the transformer in line in the middle of that coax cable. Again, make sure the shields don't touch, so it's completely isolated, and then just put a couple layers of heat shrink tubing over it to try and build it up, because I would say, even for one, or for it would last a couple times, you could just solder BNC jacks straight to the transformer, but eventually you're going to break those solid wires off of the transformer. But like I say, you could even just cut a cable in half, stick the transformer in line, put a couple layers of heat shrink tube. I mean, you could use black tape, but we all know what happens to black tape goo after a few years. It becomes a gunky mess. So, but yeah, just slide some heat shrink tubing over it, shrink it down so it's nice and tight to give it a little bit of strain relief, and that would work fine. Like I said, I like boxes, but there's just a really quick some other ideas for mounting that would be cheaper too. Like I say, if you've got a little scrap piece of prototype style perf board laying around, you could just use 2 BNC jacks transformer, or even just an old BNC cable would work just fine.